Hey everybody, and welcome to the Daily Space Weather. We're coming at you a little bit late today after some major retooling. So most of the process now finally complete. You may see some differences in today's video here at the Smash News Network, and welcome to space, by the way. You may see some differences. They're mainly associated with resolution, and let's talk about what's going on in the realm of space. Huge amount of activity kicking off in the southeastern limb. Huge number of massive solar filaments all around the solar disk, and lots more to talk about today. High likelihood of solar flares is emerging from this area down here. We'll show you sunspots, we'll show you coronal holes, and all the rest of it. Here's a fantastic zoom in. These videos are 24-hour SDO movies. It's depicting ionized helium in 304 angstroms and ionized iron in 193 angstroms. Now, like I said, there are many filaments. The likelihood of coronal mass ejections is very high, nearly 100%. We didn't get an earthly directed one yesterday, but there was certainly a lot of activity down there in the southeastern limb. Here's a great example of a prominentiary filaments rising up over the northeastern limb. Great detail and contrast there, as well as the Earth scale to help put it into perspective. Also some activity kicking off in the southwestern limb. No major CMEs coming out of that area. There is potential. Once again, the main place to watch for the next 24, and we'll be streaming it once again today, is that southeastern limb. Look at the size of this filament up here. That is indeed a spectacle. That filament approximately, I don't know, what about maybe 40 Earth diameters? Giant horseshoe-shaped filament hanging out there. There's an even closer view of it. How you like them apples? Pretty sweet indeed. And let's break down some more data here. Before we do that, there's the 171 plus 211 angstroms close-up of that new, likely large active sunspot, probably at least beta-gamma class. And here comes some more stats. So here's what's going on with sunspots yesterday plus today. A mild bit of growth here and a little bit of consolidation happening in that group. Besides that, mainly degradation here. It's a dip in the sunspot number, a dip in the radio flux. It's a dip in solar activity in general. By the way, pardon the weird keying today. I am 70% something or other. 70% hot, 30% mess. Anyway, there is the colorized magnetogram for the past. That is yesterday plus today as well. Our custom Helio viewer movies are 24 hours. These are yesterday plus today to date. So, by the way, if you enjoy the content, take a moment to visit our links. Smashomash.com is our homepage, and welcome to the Neo-Renaissance. Congratulations on realizing this channel exists. We've been doing it for pushing 6 years now, providing the most detailed daily space weather and comprehensive solar imagery you'll find in the known universe. Our affiliate/sponsor, which is also linkable below this video in the description, as well as on the homepage at smashomash.com, is Hemp Lucid. Save 10% on checkout by entering the promo code SMASHOMASH on your order. Again, enter the promo code SMASHOMASH and save 10%. Shop via our link, available again below the video in this description and on the homepage. Great products there, whether you're looking for body balms, CBD tinctures, mushroom gummies, sleep aids, and more. So check it out. HempLucid.com. Enter the promo code SMASHOMASH to save 10% on checkout. Thanks to Hemp Lucid. Let's get back to, well, this is some Earth weather. So we're interested in what volcanoes are erupting. Let me increase the size of that a little bit there. There we go. VolcanoDiscovery.com reporting that Abico is erupting in a pretty spectacular fashion there. It's producing a 13,000-foot plume of volcanic ash. Also, Subanose-jima, 8,000-foot ash plume over the Ryukyu Islands. Luatolo exploding, flight level 070. Semeru exploding, flight level 140 over East Java, Indonesia. Popocatépetl exploding in central Mexico. That's a 22,000-foot ash plume, flight level 220. Revenador producing ash and gas in Ecuador, and a 15,000-foot plume of volcanic ash. As it explodes, it's a flight level 140. Cotopaxi, flight level 220 in that same nation of Ecuador. Last but not least, Sabancaya exploding, flight level 240. It's a 24,000-foot plume of volcanic ash. And I've got a blurry screen now, and I have no idea what it's depicting. There we go. There is seismic activity for the past 90 days. Courtesy of volcanodiscovery.com. And it's been seismically pretty calm here over the past 24 hours. And this might be one of the places you're noticing some differences in the content, as we've got additional pixels for you these days. So major upgrades, compliments of the Smash team. Once again, thanks to the Smash team for increasing the probability that these videos will continue to exist, remain publicly visible, and free for all to view. Normally I would scroll up on this list automatically, but my scrolling is acting funky. Alright, that's alright. We'll just scroll up manually. Citing the quakes over a 5 magnitude. Is that map too small? Let me increase the size of that a little bit. That's a little better, I think. Again, we'll cite quakes over a 5 magnitude, and did we even have any? 0 quakes over a 5 magnitude for the past 24 hours. So that's somewhat interesting, I would say. It's a lull in earthquake activity. And let's move back to space, since there's plenty to talk about in space. Here's the past 24 hours in SDO 304 angstroms. So one of the classic wavelengths there depicting ionized helium for the past 24 hours. Again, the place to watch would be the southeastern limb. Not only do you have that huge filament there, you've got a likely new sunspot rising. This morning on Twitter, Keith Strong said that there are as many as 9 sunspots on the non-Earth facing portion of the solar disk. So, could it be the calm before the storm? That could be considered a money shot. All right, so let's get back to solar cycles and so on. The 10.7 centimeter radial flux is the next thing to cover. And what we're showing here is solar cycle progression in terms of sunspot number back to about 2005, and also the radial flux back to about 2005. We're just showing you how proportional those data sets indeed are. There's the radial flux at the bottom. As you can see, it's greatly exceeded expectations for solar cycle 25. And don't expect these lulls in activity to continue. We've still got a ways to go, nearly a year, maybe over a year even, to get to solar maximum. Keep in mind, really active solar sunspot cycles are shorter than grand minima, something that we are not currently seeing. Anyway, there's another. Let me just scroll down again to show you the sunspot number comparison to the radial flux. See how similar those graphs indeed look. The radial flux and sunspot number are directly proportional. So we've actually dropped down to 135 solar flux units. There's the 1-year graph of the 10.7 centimeter radial flux depicted by the black line. The dark red line is the 81-day average for the 10.7 centimeter radial flux. The pink line is the 30-day sunspot number average. The blue line is the Potsdam AP. That is the an average of global geomagnetism there. It's based on the KP index. And last but not least, you've got the NOAA sunspot number there, which is the red line. And of course, you can see how proportional the red and black lines are. That's the sunspot number and radial flux, respectively. Space Weather Enthusiast dashboard forecasted a little bit of geomagnetic unrest this morning. Not sure why. It doesn't even state why on the Space Weather Enthusiast dashboard page. So let's don't dwell on it and just move on to take a look at Earth's magnetic moment from space for the past 4 hours. So here's our geospace magnetosphere movie, and things are calm. We've been seeing an ongoing ramping down of a coronal hole high-speed stream as we await for some more activity to happen. That's the last 4 hours of Earth's magnetic moment from space depicting magnetohydrodynamic pressure. This depicts magnetic flux density at the surface level, changes in Earth's B field. So geospace delta B, Earth's magnetic moment from the ground level. And if you thought the poles are going to flip, well, why aren't we seeing evidence of it on this map daily? Probably because the poles aren't going to flip. That's my story, and I'm sticking to it until I see some evidence that they will flip. Next, the planetary K-index currently at 1.33. It is a geomagnetically calm condition. Here are our GOES magnetometers. And those are looking pretty smooth here. No big deal going on with those. A little bit of variation happening there around midnight local time for the GOES 16. That's what these N's and M's depict. That's noon and midnight local time for the satellites. They are geosynchronous satellites located at near equatorial orbits. They're at about 23,500 miles of altitude way up there toward the outer portion of the outer Van Allen belts. Next, our top view ecliptic plane field plot. Earth has just recently entered a South Pole current sheet depicted here in red. No changes expected to come anytime soon for that. So that's the South Pole current sheet. Over here is the North Pole current sheet. You can expect that to persist for the coming days. And next we'll show the line of sight solar field plot. There you've got your solar B field in blue, north polar field in red, south polar field in green. Again, pardon my weird keying. I didn't think my yellowish shirt would look so strangely today. I was not trying to look like I'm fading into space. Next, our line of sight coronal hole plot. Super important for showing solar cycle progression, and there's been a huge uptick here in South Pole-oriented coronal holes. Look at all the South Pole-oriented coronal holes showing up here on the eastern limb. Massive number of coronal holes there. Some of them right next to huge plasma filaments. Let's take a look at those. And here is 211 angstroms. So these coronal holes over here are South Pole. And these coronal holes over here are North Pole. The sector boundary crossing is something like that. Earth is in a South Pole current sheet, and let's move to sunspots. So there has been a new named group there, 3307. Besides that, I'm not seeing a lot of activity. I'm not aware of any new sunspot groups. But let's take a look at what we see here on our 24-hour SDO continuum. That group down there appears to be at least beta-gamma class. Besides that, things pretty chill. Let's take a close-up look at this series of sunspot groups in the northern hemisphere. There is 1,600 plus 1,700 angstroms. You can see those are mostly stable, although one of the umbra here migrating off. That North Pole umbra, interestingly, actually moving a bit to the north. And sunspots do have the characteristic of moving toward the pole, toward the equator most of the time. That umbra there off to the races, slightly moving to the north. Anyway, next we'll go to solar flares and energetic particles. Energetic particles still flatlined here. We did have the largest flare of the past 24 hours, just as we did show prep. So that was at about 12:10 universal time. Peak flux there just below a C5 class, C4.5 class. And let's see what's shaken. Did it come from down here? I wouldn't be surprised if it did. Let's see. And actually, I think that most recent flare... Not sure on that one. Not sure if it came from this group of sunspots. Or down in the southeastern limb. Anyway, let's take a closer look here. Here is the past 24 hours. That's 2 wavelengths, by the way. That's 94 plus 131 angstroms. I think that flare may have come from this group here. Anyway, it wasn't a huge flare. It wasn't M class or anything like that. Here's another close-up of this southeastern limb. You're going to see a lot of that southeastern limb in the coming days. And thanks for leaving comments. Cookie Spacey. We appreciate your being one of our spaced out viewers. All right, so let's get back to stats here. Again, largest flare of the past 24 hours occurred while we did show prep. A common feature on the channel. Is it luck? Is it divine providence? Is it both? Or is it by design? As I get older, I realize that there is nothing random in the universe. Anyway, as we're always interested in what's going on overhead, this is a star chart for Lehigh Valley, Pennsylvania. If you're up after dusk, you'll get a great view of Venus, the third brightest object in the entire sky. Venus there rising behind the sun as the sun chases a crescent moon, Jupiter and Mercury, across the Lehigh Valley sky. Next, the solar system forecast. This is where things are now. Mercury is on its way over to the gas giant side of the solar system, breaking ranks with the terrestrial planets Mars and Venus. Here's your 1-week forecast. That is where things will be on the 23rd. We will have a crescent waxing moon by that point. And let's take a look at coronagraphs. So here are yesterday's coronagraphs. Again, we've got no earthly directed coronal mass ejections here. So that was sort of going out on a limb yesterday. I just wanted to forecast that just for fun. I knew there would be coronal mass ejections. I didn't really particularly expect them to be earthly directed if they came from the southeast limb, as they did. But nonetheless, expect more CMEs today. Here are today's coronagraph images so far from George Mason University. And let's move on to look at stereo A also. We'll show you stereo A as well as the Soho Lasco C3. So there are those images. Keep in mind they are not synced, although those images, like most of our data, do show time and date stamps. Looks like the Pleiades showing up there on the Soho Lasco C3 in the upper left. The Seven Sisters. A bunch of very bright, very hot, very large, massive stars. All right, so here are our custom coronagraphs. That's the past 24 hours. That's SDO 193 angstroms along with the Soho Lasco C2 and C3. Most of the CME activity there coming out of the southeastern limb. And again, not likely to be earthly directed. Look for activity to continue down there. And look for the filament fest to continue, because the filament fest is absolutely berserk. So prepare for that. There's going to be a lot more CMEs in the coming days and or weeks. So here's the situation at El Teide, Spain's ground-based solar observatory. And look at the size of the filaments. I mean, those filaments are truly berserk. Here's one having just ejected, it looks like. Or maybe it collapsed, but it definitely looked like it went mobile. That's the hydrogen alpha imagery. And if you want to name filaments after your favorite or least favorite living humans, do it over on Twitter. Hashtag name that filament. And here's the past couple of hours from the GOES 16 SUVI. Here's the past 24 hours from the SDO. Spectacular imagery there. Perhaps some activity rising in the northeast as well as the southeast. In fact, we may see a sunspot rise earlier up here. Another indication that whatever is rising down there is a huge active region. Also seeing some brightening happening way down here at quite high latitudes there in the south. Anyway, back to the GOES 16 SUVI. This depicts the last about 2.5 hours. That's 304 angstroms, ionized helium. And that brings us to our bonus features segments. We used to separate them. It gave us less views on YouTube. Yeah, it gave us less views. So we have them all together once again. So here is our satellites community dashboard here, looking for charging hazards, and at the moment it is smooth sailing for satellites, no charging hazards. Electron flux here in an operating range. There is the 1-year chart of the electron flux. Kind of low levels here. And I believe NOAA is expecting an uptick by tomorrow. I would tend to agree with that, as we've seen a coronal hole high-speed stream subside. No arguments with the forecast model. The green boxes are the forecast. The yellow diamonds are the observation. Now, that is measured at the F layer of the ionosphere, so we show that daily on the channel as well. Perhaps the ionosphere contains information that we're not aware of yet. You never know where the variables are going to fall. So if you suspect correlations between data sets, especially if you expect causation, perhaps because you have a valid physics explanation of the causation, we appreciate that. So put it in the comments, or drop us a line on our forum at smashomash.com/forum. And if you want to read about our mission, go read that as well. smashomash.com/forum/mission. We're interested in things with predictive value on the channel, not things to frighten people. Here is our F layer of the ionosphere in anomalygram. It depicts anomaly in megahertz from a 30-day median, as opposed to the raw vibrational frequency that we showed you on the previous pane. Or you could say slide, or you could say tab. Don't be a pain and slide your tab off of a cliff. Anyway, that's the latest image. Wait for it. There's the latest image. That's 1330 universal time ionogram and 1330 universal time anomalygram. Mostly low-frequency anomalies showing up here at the moment. The total electron content will depict the free electrons from your GPS satellite down to your handset. That's about a 12,500-mile run. And here is the total electron content on a global scale. This will show you the most likely places to see GPS errors. And when we see that electron flux rise up, you should see less GPS errors. At the moment, there are quite a bit of electron content out of place there, you could say. And that is more consistent with low electron flux than high electron flux. So that's the current situation, the coupled thermosphere, ionosphere, plasmasphere electrodynamics model. And we're going to show the anomalygram for total electron content for the North American region. So that's the full world view. Turn on your Wi-Fi location accuracy if you expect GPS errors. And there's the North American total electron content. Some significant variations there happening off the coast of Baja California. Some high to low frequency. High to low electron counts, as the total electron content is literally depicting a count of the free electrons. And it does give you insight into what's going on in the magnetosphere. Anyway, if you need to pause the video on this frame, feel free if you're not familiar with the penetration of electromagnetic radiation, thermospheric temperatures, and molecular concentrations. We show that to explain to people that slice of the atmosphere, the F layer, which we showed a few frames ago, the ionosphere. There it is, 300 kilometers of altitude is the location of that. Here's the latest SDO magnetogram and latest SDO intensitygram. So there you go. Looks like no major changes. Do we see any new sunspots rising yet around the eastern limb? Not really. There might be a new named group there in the east. It'll have to be there about 12 hours for that to happen. And let's move to our meteorology segment. Could that be a new named group right there? I'm not sure. Let us know in the comments what you think. Before we go to the meteorology segment, a quick reminder that essential amino acids cannot be produced in the body. They must be consumed via diet. So what we did is we created an Amazon shop for people just like you to get some insight into what nutritional supplements I take. Now, I became a pro cyclist back in 1999 on the cross-country mountain bike. And hey, now that we can endorse some products, we do. In fact, you can even buy these very sunglasses. They are on one of the lists there. L-lysine is what we're talking about when it comes to essential amino acids. There's a list called Spacewear. So check that out. Check out the bulk spices and lots more on the Amazon shop. More coming there, as well as office furniture and all kinds of stuff. Official endorsements. We don't endorse things that we aren't paid for on the channel. And let's take a look at ocean currents and sea surface temperature anomaly. So here we're looking at the U.S. We've got some wild variations of the temperatures in the Great Lakes right now. Huron is anomalously cold. Michigan has anomalously warm and cold spots. Erie is kind of on the warm side. And Ontario is warm in the east and average in the rest. Anyway, we're showing this mainly for the Gulf Stream purposes. A lot of anomalously cold water here mixed in. So there is a stagnant bit of the Gulf Stream there. The current is 0 miles per hour. And the temperature is 9.3 degrees Fahrenheit below normal. Here's another very slow-moving spot, 9.7 degrees Fahrenheit below normal. However, this warmer water is still moving. So that's moving at 2.8 miles an hour. Down here, this anomalously warm water is moving at 2.9 miles an hour. And if you're expecting a year without a summer in Europe, sorry, your grand solar minimum has been canceled. Canceled, folks. Now, there is a lot of anomalously cold water around Greenland, as there is a lot of snow melting. Also, cold water around Baja California and warm water around Washington. Anyway, let's blast through meteorology. We're coming at you late today. We didn't want the video to be too lengthy. Here are the surface winds of the eastern world. Strong cyclonic system there off the coast of Japan. These are the jet streams of this side of the planet. Jet streams of the west depicted here. Huge, powerful convergence happening there in the Atlantic Ocean. Here are the surface winds for the western world. Surface winds of the central world. Very strong cyclone here south of the equator in the Indian Ocean there. Nobody's around to see it. It's probably producing some high seas indeed. Here are the jet streams of Europe, Africa, and the Middle East. All right, next our clouds and fog view. We're actually showing the visible satellite today since we came so late. Showing the visible satellite over the Americas. Yes, Crescent Earth. Depicted through fake NASA Photoshop imagery, CGIing a crescent-shaped planet onto a spherical template, just to fool you into thinking that the planet's spherical. Just kidding, folks. People have known for thousands of years that the planet is shaped like a sphere. NASA is not trying to tell anybody that the planet is an oblate spheroid. Next, our weather.gov map. If your location's lit, click your location at weather.gov. We'll briefly scroll down and show you the key. Looks like a lot of snow about to melt in Alaska. or maybe some heavy rains, but there are flood watches there. Again, if your location's lit, click your location at weather.gov, the National Weather Service website. Weather.gov. Here are some forecasts. Temperature anomaly is the first that will show. That depicts anomaly in degrees Celsius. That is a 72-hour GFS forecast as unseasonably hot temperatures continue in the Pacific Northwest, getting as high as like 16 degrees Celsius above normal, while the northeastern U.S. staying a little on the cool side. Next, your pressure and precipitation forecast based on the same model. That's, again, the GFS 72-hour model. We've got some cold air going to blast into southeastern Colorado, Nebraska, Oklahoma for some severe weather in about 3 days. There you can see some quite concentrated cells there. I suspect it's because cold air from Canada mixing in with warm, moist air from the Gulf or from Mexico. That's your 72-hour GFS pressure and precipitation forecast. We've also got your lightning mapper. Once again, some heavy lightning in southeastern Mexico. And let's look at a real-time lightning map to see if we've got any terrestrial strikes. Southern Texas not getting a respite. Hey, Corpus Christi. There's thunder rolling in there. Thunder rolling in at Corpus Christi, Texas, according to our real-time lightning map at lightningmaps.org. Pretty minor. That's the situation. Our real-time lightning map. And how about a satellite map? There's a great animated satellite map as the sun rises over the Rockies. And finally, the West Coast. That's from windy.com, by the way. They've got a mobile app that you can download for free. Lots of great layers to view there if you're concerned about things, everything from wildfires to soil moisture to snow depth. And let's close this mother out, but a quick reminder, don't forget to become a member of the Smash Team. SmashOnMash.com/Smash Team. Did you know we make just this side of nothing to put these videos on YouTube? Yeah, it's true, folks. It's true. So consider becoming a member of the Smash Team at SmashOnMash.com/Smash Team. You'll be able to find all of our social media and so on the homepage as well as below this video. Thanks especially to our Gold and Silver Smash Team members. They're increasing the probability these videos will continue to remain existent, publicly visible, and free for all to view. There's also a bronze level. We send out emails about natural disasters to all the levels. Thanks once again to the Gold and Silver Smash Team levels. These videos are brought to you in part by their charitable contributions. They're not really we're not a .org. We're not a nonprofit organization yet. It's coming, but we're not one yet. Anyway, here's your U.S. Doppler radar map. That's the full 50 states. We'll focus on the lower 48. There is clouds and fog depicted by 3.9 micrometer infrared radiation. And there is the water vapor map. It looks like clear skies are coming to Missouri as I see a high pressure zone depicted by this dry mass of air right here. Great example of a high pressure zone rolling in there. It's kind of a small one. It's sort of concentrated. Clear skies coming to the state of Missouri. Anyway, here's your recap. U.S. Doppler radar. Clouds and fog. And there is the water vapor. That should clear things up if your Doppler is unclear as to what's going to happen next. Check out the water vapor map. Again, check out the links below the video. Support the channel. Thanks to everybody who has. We'll see you soon here at the Smash News Network, least busted name in news. I've been your host, Dan, a.k.a. Smash-O-Mash, signing off. And may that solar wind be at your back.